chapter, what I wanted to do is just go a little more into depth about the analyses of observational data. Now, your book and the PowerPoints go into more details about this, but I just wanted to highlight this overview of all the observational methods that are discussed in this class. So the kind of greatest breakup that we have is direct versus indirect observation. Indirect are the simplest, and these are observations that basically aren't done live or aren't done while the person's actually engaging in the behavior. They're done after the behavior. And so there's two different types that you'll talk about with those, the physical traces and archival records. But again, the key to indirect observations is these are not behaviors that are watched while they're happening. In contrast, direct observations are behaviors that are being watched while they're being done or while they're being behaved. We can further break down direct observation into observation without intervention or observation with intervention. Observation without intervention is called naturalistic observation. This is watching behavior as it occurs without doing any kind of intervention, any influencing the behavior in any way. For example, some studies are interested in children's behavior at recess, and so they may go to recess, watch what children are doing, record it in some way, but they're not going to intervene, and they're hoping that this doesn't influence the behavior in any way. So again, this is naturalistic because we're hoping to observe the natural behavior. However, sometimes behaviors that we're interested in don't happen very often, and so we have to engage in some kind of intervention. So for example, sometimes people are interested in children's behavior when they're trying to enter a group. Not all children enter a group. Sometimes they don't enter groups very often, and so if you just go observe a child on a random day, don't intervene in any way, you're not very likely to catch that child engaging in an entry behavior. So we have to do some kind of intervention to get that specific behavior. Now, there are three different kinds of intervention. Participant observation is when the observer actually participates in the activity. A structured observation is an observation in which the participant or the observers set up a specific set of behaviors for the participants to do so they can watch a specific behavior. With entry-seeking example, there was one study in which they were interested in children's entry-seeking behaviors. They brought kids in play groups and took children out one at a time to do some extra activities and then sent them back into the group. So with that structure, they had a specific set of circumstances in which they could observe the children and could watch how all children engage in entry. And then finally, a field experiment is an experiment in which there's an independent and dependent variable. There's something explicitly manipulated, and they're testing the response to those being at the dependent variable. It's called a field experiment because typically it's done in the field rather than in the lab. An example of this might be social psychology experiments that are interested in the influence of bystanders in people's likelihood to intervene. For example, in a bank robbery. So they might stage a bank robbery with actors and everything, have a couple of participants, and then manipulate how many people are around. Is there one other person around, or are there 5 other people around? Because you're manipulating something, you've got an experiment, but again, what they're observing, their dependent variable is their observations of the person's behavior. So this is a good thing to go back to look at all the different possible types of observations. Now, although recording behavior might seem like a kind of trivial detail, it's actually very important in terms of determining what kind of analysis you can do. In your assignment for this chapter, you're going to actually be going and observing behavior, and you'll do 2 separate types of observations, so you can get a sense of how big of a difference it makes. The comprehensive records basically describe everything that's going on. They're recording everything that's happening in the moment. There's 2 different types. So a narrative record is basically a reproduction of behavior as it originally occurred. And afterwards, kind of classifications are made. Video and audio recordings can also be used to record a comprehensive record. So again, you had everything that possibly happened. These are really useful because afterwards you can go back and look at them. So for example, if I'm videotaping children's interactions, and I'm interested in bullying behavior, I I might videotape the interactions, go back and watch them and record what the bully is doing, but then I might notice something interesting is going on with the victim. And the advantage that video recording gives me is that I can go back and watch it again and say, okay, now I'm going to focus on what's happening with the victim. However, while comprehensive records are wonderful and very useful, they're also a lot of work and require some things that not all participants agree to, like video recording. So another strategy for collecting or recording behavior is selecting specific behaviors that the researcher is interested in. In this case, the researcher has to know what their hypotheses are to begin with, what are they interested in, and then they create a checklist of the behavior or some kind of rating scale. So if I'm observing children at recess, I'm interested in their social behavior. I want to know how often they're alone and how often they're with other children. I've defined these behaviors, and what I'm going to do is go watch them and count how many times they engage in each of those behaviors. Now, which method or strategy used for recording behavior is really important because it determines how you can analyze and summarize and report your results. Part of the reason it determines this is because it determines your measurement scale. So there are 4 types of scales, and you can do different types of analysis with each. Nominal scales are categorical things. Think of whether you can think of a name or a category, something with no specific one that is clearly better than the other. So things like eye color, your major, your favorite ice cream flavor, your favorite TV show. These are things that we can't necessarily rank. They're just a category. Ordinal gets a little more complex, and with ordinal data, we're putting things in some kind of ranked order, but it doesn't tell us how much of a difference there is. So, for example, I could ask participants to arrange their political candidates in order of preference, but I don't know whether they really, really like number 1 or whether number 1 and 2 are pretty good. So that's the limitation of ordinal data. Interval data determines is that in which there's a specific set of differences between the scores, and the scores have equal intervals, equal distances between them. So, for example, temperature. So we know that each degree is different, a specific amount. So the difference between 32 degrees and 33 degrees is the same difference between 72 and 73 degrees. What distinguishes interval from ratio, which also has a specific set amount, is with interval data, there is no true zero. So 0 degrees Fahrenheit does not mean that there's no temperature at all. Likewise, IQ. We suspect that a person with an IQ of 100 has an equal distance from an IQ of 90 and an IQ of 110. But an IQ of 0 doesn't necessarily mean that a person has 0 intelligence. Ratio scales, in contrast, have a true 0. So you can think of things like inches on a ruler. It is possible to have 0 inches. You can also think of time in a race. It's 0 seconds, and that means that they haven't even started the race. And each point is equally as far as they go. So you can think of things like counting the number of times a child leaves the room, how many times a child hits another child, weight, age, height, all of these things have true zeros. Which level of measurement we collect determines which analysis. So if we collect qualitative analyses, we're collecting some kind of verbal summary. So we do this with various types of data where we're looking kind of overall and making some kind of verbal summary about what's going on. We're not looking at it in terms of number. Qualitative is about the quality of the behavior. When we're looking at this, we might be looking at huge transcripts of interaction records, and we have to reduce the data from how we have to summarize the record. Typically, the way that's done is through coding, where you identify the units of behavior using specific criteria. So say, how many times does this person use this word, or how often does this come up, when does this come up? But it's really important to remember that qualitative analysis is a verbal summary, whereas quantitative analysis has to do with numbers. So like I said, quantitative analysis is a numerical summary of observations. We call this descriptive statistics often because they're describing what's going on. But on the measurement scale. If you have a nominal scale, if you're counting the number of times a child is alone, a child is victimized, a child is with other people, basically the only descriptive statistic you can look at is the relative frequency. So how many times a behavior is observed divided by the total number of observations. So maybe we find that 75% of the people who we observed ate alone, or 75% of the time people who are observed are alone, and 25% of the time they're with other people. That relative frequency, the percentage of time they engage in the behavior, is the data that we can use for nominal scales. With ordinal scales, we can rank percentages. So we can say 54% of people ranked lows as their favorite herders. With interval and ratio data, we can do a lot more. We can look at the means, we can look at the standard deviations, or kind of the average distance from the mean. So you can see that we can get a lot more information from quantitative analyses that we're using. Inter-observer reliability is another important thing to consider with observational data. Remember that reliability has to do with the consistency in the data, and with inter-observer reliability, what we're asking is, do independent observers who are watching the same behavior record the event in the same way? So we need to have some kind of measure of the agreement between observers so we know how good are we at agreeing on a specific behavior. What we can do is we can look at what's called a correlation, and if you're using ordinal data, you look at a Spearman rank order correlation. If you're using interval ratio data, you can look at a Pearson correlation. And I'm going to go a little more into the correlation, but in general, the idea is we want to know how closely do the two observers agree. Once you've listened to this, I've got several links on Moodle to further help you understand a correlation. But in general, a correlation is the relationship or association between two variables. When we're talking about inter-observer reliability, we're talking about the relationship between one observer's code or observations and the second observer's observations. How closely are they related? There's a specific statistic called the correlation coefficient that tells us two things about the correlation, or two things about the relationship between the two. The direction of the association. So when we're talking about direction of the association, we're saying when one variable increases, does the other also increase? And it also tells us about the strength of the relationship. So how fast does the other increase? Correlations range from -1 to +1. And a score of 0 indicates there's no correlation. If it's a negative score, then it indicates a negative relationship. Positive score indicates a positive relationship. Now, a perfect correlation is a 1, positive 1 or negative 1. Almost all of the relationships that psychologists study are less than perfect. So psychologists consider a correlation of 0.7 or 0.8 a really, really strong correlation. Just to give you a sense of what we're talking about, if I'm looking at someone standing in college as a freshman, sophomore, or junior, and the number of years they've been in college, I'd expect a close to 1-to-1 relationship. Most freshmen have only been in college 1 year, most sophomores have been in college 2 years, and so on. However, there are a few exceptions. If I'm looking at something like height and IQ, though, I wouldn't expect those two things to be related, so the correlation would probably be close to 0. Okay, so when we're thinking about correlations, the best way to visualize them is something that's called a scatter plot. So as you can see, we've got 5 scatter plots here. If you look at the one in the top left corner, there are 2 that are called axes, or 2 lines. The bottom line is the x-axis, that's the person's score on the first variable. The vertical line is the y-axis, that's the person's score on the second variable. Each dot indicates one person's score on each of the 2 variables. So let's just hypothetically say that x is equal to SAT scores and y equals GPA. So we want to know, does knowing someone's SAT score let you predict their GPA? So if we look at the top left graph, what we have is a perfect positive correlation. Since it's positive, we know it's a positive number. Since it's perfect, we know it's 1. So what this tells us is people with lower SAT scores have lower college GPAs, And people with higher SAT scores have higher college GPAs. The middle top graph shows us a modest positive association. You know that it's not as strong because the points are spread out. In the first one, the points are nearly exactly aligned. In the second one, the points are a little more spread out. So what this tells us is, in general, people who have higher SAT scores have higher GPA scores. However, there are some exceptions. You should see if you can find some points on the line that indicate that someone has a higher SAT score but a lower GPA than another person. The third graph shows no association. So this would be a correlation of 0. What you can see is there's no general trend. You couldn't draw a line through the data and kind of generally show what's going on. If we move down to the bottom two graphs, now we're looking at negative correlations. You can see that the line goes in a different direction. So what negative correlations tell you is as one variable goes up, the second variable goes down. Remember, with a positive correlation, as one variable goes up, the other one also goes up. So we might expect a negative correlation between something like age and temper tantrums. So let's say that X is the child's age and Y is the number of temper tantrums. What you can see, the first one is a perfect negative correlation, which means a correlation of -1. We can see that as children get older, they tend to have fewer temper tantrums. Modest negative correlation shows the same thing, but again, there are some exceptions.